Space Leadership in the Coming Year. I'm Tonya Hall, and joining me is Dr. James Vedda, Senior Policy Analyst at the Aerospace Corporation. Welcome, Jim.
Thanks for having me on the show.
What does the Aerospace Corporation do?
Aerospace Corporation has been around for 60 years as an engineering firm that helps mostly the government do its space programs of all kinds. That's national security programs, civil programs like NASA and NOAA. We also do some work for the commercial sector. So mainly we're an engineering company, but I work in a policy office in the Washington, D.C. area, while the headquarters of the company is in Los Angeles.
In the early years of spaceflight, governments of large countries ran the show. How has the privatization and commercialization of space operations changed the concept of the leadership in space?
In the early days, there was nobody else who could do it because you had to gather the expertise and have the resources to put together space systems that were being built from scratch. So there really wasn't much choice about who was going to lead that effort. It had to be the government because they were the only ones who were able to pull it all together. Now, as we've evolved in our experience with space flight and all the space applications that we use, that expertise has expanded throughout the private sector, and it has expanded to other countries. And now there's a much wider community of people with expertise and experience in the space operations that make it possible for innovation in a private sector environment that does not really necessarily need the government to be there. Government is still a great customer for all of this, and they will be for a long time to come, but they're not the whole show anymore. And that's actually a good thing because the way that we're going to expand in space exploration and development is going to depend on more resources than any government or group of governments is going to be able to apply to that effort.
What space accomplishments and success stories are we likely to celebrate in the coming year? And who's going to be responsible for making them?
Well, we have a lot of important things going on that for a lot of people may seem like behind the scenes, but really are going to be critical for the evolution of the next generation of space activity. One of those is to figure out how to do space traffic management. We are launching large numbers of spacecraft up there of all sizes to do a number of different kinds of applications. And it's getting difficult to keep the tracking straight so we know where everything is at and are able to avoid conjunctions, in other words, collisions between spacecraft, to make sure that they're not getting in each other's way in using the spectrum to transmit back and forth. So that has become a lot more difficult with the vast increase in the number of spacecraft being launched because of low Earth orbit constellations that are going to have hundreds or even thousands of satellites. So solving that problem is something that has to happen in the next few years. So that's going to be very big. Also, another thing that's going to have to happen is the continuation of NASA's Artemis program to determine exactly what human space flight is going to be doing, at least in our country's contribution to it over the next few years. And that means successfully executing their moon program. The next couple of years are going to be critical in that. And at the same time, the new Space Force that was formed a year ago and still has a lot of maturing to do. What is the Space Force supposed to do? What components, both personnel and technical components, are going to be put together to do the job? That's something that is still in the works, and there are a lot of high hopes for its accomplishments, but it's still early.
So, something you said before, does space traffic management include knowing where leftover debris is? And how are we managing this?
Yes, it does include tracking of debris as well as operational satellites. And in fact, in the in the number of components tracked, the debris is far out ahead. There is much greater numbers. We on a daily basis track well in excess of 20,000 pieces of debris. And that's just the ones that we can pick up with current systems. We know there's even more out there that's smaller and harder to track. So we have to keep track of, not only the operational systems, but the stuff that's been left behind in some cases for many, many years. There are pieces of debris that are still up there from decades ago. And this can be spacecraft that are no longer functioning. It can be old booster stages that put up a payload years ago and just kind of hung around up there. Or it could be pieces of a spacecraft that were either purposely or accidentally deployed and are just floating around out there. So there's really a lot to track, and it's very complicated business.
What scientific or technological convergence or disruption is likely to be a wild card for either commercialization or exploration or national defense?
There's a lot of people that are counting on space tourism to be the thing that breaks everything out and causes a renaissance in space. I'm a little skeptical of that myself. But if there is much larger scale human travel into space, that's going to change the picture quite a lot. That means there are going to be whole new kinds of facilities that will be in space, whether they be habitats or manufacturing facilities, or whatever that humans may decide to do up there. The other thing will be the ability to use resources in space, like the water that everybody's talking about, water ice on the moon, right? And they say, oh, this opens up everything for us. Well, okay, we've got a lot of work to get there, though. I mean, it's water ice. It's very cold. It's in the bottom of dark craters. We have to figure out how to extract that stuff and turn it into useful water, or split it up into hydrogen and oxygen and turn it into fuel and oxidizer for our rockets. Yeah, theoretically that's possible. We've got a lot of work to do to figure out exactly how we're going to pull that off. If we can build those human systems and figure out how to use those basic resources like water in space, those will be huge breakthroughs.
On the subject of human travel, with the increasing sophistication of robotics, machine based autonomy, and spacecraft design, how important is it for humankind to be included in interplanetary exploration?
Well, there is a wide range of opinions on this. I tend to lean towards the idea that humans should go into space to do the things that they are uniquely qualified to do, and robots should do everything else. So sometimes you will hear people try to measure the progress in space by how many people are we sending up there, how many people are living and working up there. You've heard prominent figures in the space community and including people like Jeff Bezos come out and say, well, we want to work up to the point where there's 1,000 people or 1,000,000 people working in space. And to that I say, well, wait a minute, is the number of people really the right metric? It should be, what are you accomplishing there that generates value? And how much do people really have to be involved? Because it's a very hazardous place to work, and it's very expensive to work there for people with all the systems you need to support humans. So you should actually try to minimize the number of people that are living and working in space if you can get robotics to do the rest. Now, I know not everybody agrees with me on that, but I think that the number of humans in space is not our absolute best metric for how much progress we're making.
So true. What key signals and trends would you suggest space investors, inventors, and entrepreneurs watch for in the coming year?
Well, I think that the breakthroughs that we're going to be seeing soon are a new paradigm of space operations. We already know that we can have profitable space operations with satellite communications. We're doing a pretty good job with remote sensing, including commercial remote sensing. Those are applications which require the transmission of electromagnetic signals back and forth. Uh, in the case of remote sensing, you have, satellites are taking selfies of the Earth, right? You have navigation satellites, which are bouncing signals around that help us find out where we are as we triangulate the signals. Okay, that's all great, but it's all dependent on the same thing, those electromagnetic signals bouncing around. You put a little relay station up there and you're off and running. We're getting into a new paradigm, which is going to be the actual physical interaction of spacecraft and the building of space stations, the manufacturing, the on-orbit servicing. All that physical interaction stuff is relatively new. It's been special purpose things before. I mean, you needed to have rendezvous and docking of spacecraft in order to do the Apollo project, but that was a rare occasion. It's going to become a routine thing. So the physical interaction and the movement around in space, especially in cislunar space, is going to be the important thing. So we're going to see an emergence of an industry that deals with those physical realities, and I think on-orbit servicing is going to be one of the early ones to make its mark.
Dr. James A. Vedda, Senior Policy Analyst at the Aerospace Corporation. Thanks for joining us, Jim. I really appreciate your time. If somebody wants to connect with you, what's the best way they can do that?
Well, I can be found on LinkedIn, but I hope people will also look at our webpage for that our company has for our policy center, which is aerospace.org/policy. And there's a lot of free material that you can download from there about policy topics related to space of all types. So please visit that site.
Will do. And find more of my interviews right here on iTunes, Spotify, and YouTube, or at tonyahall.net. Thanks for watching.